Hey guys, and welcome back. Today we are continuing with Unit 2, all about congruent. So today is congruent parts, part 2. And what is great is this is really just a review of yesterday's lesson. So if you remember yesterday, we were talking about how to write our congruent statements, how to match up our corresponding parts, everything like that. So remember that order matters, okay? So you can't just write a congruent statement in any order. You have to make sure that your corresponding pieces are lining up. And we'll write that down too. Corresponding parts are congruent. So the first thing that we are going to look at is I am going to give you an image of two triangles, and I'm going to give you a statement, and you just have to determine if that statement is the correct statement. Like, is it going in the correct order? Okay, so when we look at this one right here, here is our image, okay? And then you can see our statement in the symbols and written out. They both say triangle ABC is congruent to triangle FED. Okay, so what you need to look at right now is this the correct statement? So is the statement true or false? All right, so hopefully you said true. And here is how we can do it. You guys know me, I am a big fan of color. So I like to use my color. So like right here, I have AB and FE. So if I look at my images, are those the corresponding pieces? And they are indeed. Then I have BC and ED. And again, those are the corresponding pieces. And then last one, AC and FD. And we'll see that all of those are corresponding. So it is indeed true. So if using highlighters or colors or whatever helps you, absolutely do that. Because we're going to do a whole bunch of these, okay? All right. Next one, giving this, we're just going to call it a quadrilateral because it's a four-sided figure. It's kind of a weird four-sided figure, but quadrilateral PZJM is congruent to quadrilateral LYXB. So is that going in the correct order? So is that statement true or false? All right. This one is false, okay? And how we can check it, so I know, I'm just basically going to do the same thing I did on the last one. Here is PZ, and what the heck? LY, that's not even part of the shape, okay? So LY doesn't even exist. So that one was a little bit easier because it literally is not even a segment on the shape, okay? All right, let's look at our third one. You guys know the drill now. So given the image, true or false, triangle JKL is congruent to triangle QRS. All right, good job. False again. Okay. And remember, it's not, do they look like they're the same image? It's, is the order correct? Is the order, so is the congruence statement correct? So that's what's important here. All right. Looking, let's see, JK is this one. QR is this one. And so what I can see is that JK is the hypotenuse, which is known as the longest side. Okay, but QR is a leg. The legs connect the 90-degree angle. Okay, and you can see that they're not in the same place. Okay. All right. I think we're going to do one more like this. Let's see. Yeah. One more. So looking at the image, is pentagon ABCDE congruent to pentagon PQRST? All right, so on this one, technically, you could have a bunch of different congruent statements for this, okay? So reminder that a regular pentagon, or really a regular polygon of any sort, means that all sides and angles are congruent. And so essentially what that means is that, yes, while AB is congruent to PQ, it could be congruent to any of those sides. So we could have written this in a bunch of different ways. So let's just write that down. So this is true, okay? But we could have multiple congruence statements for this one. So that's how it just gets a little bit tricky there. Okay, sorry, there we go. If you need to write that down, go ahead and pause. I'm going to keep moving on though. That's the great thing about a video is that you can pause at any point. Okay. All right, next one. It says triangle PQR is congruent to which triangle? And you can use tracing paper to check. So remember, we are starting with triangle PQR. That's this one. And which triangle is it going to be congruent to? All right. So you should have said triangle MNL. It's going to be this triangle over here. Okay, so triangle MNL. And if you had used your patty paper, you would have seen that that was in the correct place and everything like that. Okay. All right. Next one. We are going to show a sequence of rigid motions that takes PQR to MNL. Okay. So what we can do, if you remember, we can do actually a lot of different things like this, okay? But I know that P has to line up with M. So if you remember when we were talking about sequences of rigid motions and stuff, that we always wanted to start with translate, then we wanted to rotate, and then we wanted to reflect if possible, okay? And so that's exactly what I'm going to do. So I'm going to start by translate triangle PQR from P to M. Okay, so basically it's just going to take it like this, and I'm going to do a rough sketch. If you wanted to use your patty paper, obviously you could, but just to save a little time so you're not staring at my knuckles. So this is point P now, R is up here, and Q is here. Okay. Then the next thing that I know is that R has to land on L. So I can take R and rotate it until it's on L. So I'm going to rotate, and that direction is counterclockwise. And we're going to do it around M because this is the point that we don't want to move. We already have P and M lined up, so that's why we want to do it right there. So rotate counterclockwise around M until R lands on L. Okay, so then at that point, our triangle, again, just doing kind of a rough sketch here. So R will be here and Q will be here. And then the last thing is that Q should line up on N. And I can see that if I just reflect it over like that, I will get that. So we will reflect over ML. Okay. So that is a sequence that will get the triangle onto the other. And we know that if there is a sequence of rigid motions that maps one, we'll say figure, that way it works for everything, one figure to another, then the figures are congruent. Figures are congruent. Okay, that's actually like our definition of congruence, if you remember from the last chapter. All right, Again, if you need to pause it, you are welcome to pause it. Next thing, super important one, is CPCFC, and that stands for corresponding parts of congruent figures are congruent. Okay, so you also may hear this as CPCTC, and it's the same thing, but right here instead of figures, it's triangles. So just so you're aware, you might hear it in both directions. So looking at our two triangles here, I want you to pick the correct congruent statement. So if I say triangle RQP is congruent to triangle what would have to go in that spot? All right, good. So RQ is congruent to FE. QP is congruent to ED. So this would have to be triangle FED. All right. Couple more. Next one says, are these parts congruent? Triangle ABD is a rotation of triangle CBD around point E by 180 degrees. Is angle ABD congruent to triangle CDB? If not, which angle is it congruent to? So I just want to remind you of a couple things. We know that a rotation of 180 degrees takes lines to parallel lines. And you might be like, how is that going to help us? Well, 180 degree rotation around that means that this line is parallel to this line, and this line is parallel to this line. Okay. So now if I look at this, triangle is, I'm sorry, not triangle, ADB, that's down here. So this triangle, and CDB, this triangle. And it wants to know if those are going to be congruent to each other. And the answer is no. So I'm going to make 2 marks here. And that's because they are not like alternate interior. If I take this angle, and you could even use patty paper, and I rotate it all the way around, it is going to line up right there. So I can say that angle ADB is congruent to angle CBD, okay? And that's because we know now that CB is parallel to AD, and so these two angles are alternate interior angles. But remember, we could have used some patty paper here, okay? All right, let's look at our next example. It says, are these parts congruent? So polygon HIJKL is a reflection and translation of this polygon down here. Is segment KJ congruent to segment NM? All right, so the answer to that is no, okay? So remember, it was a reflection, okay? And then a translation. So if I look at this, NM is going to line up with KL when we do that. So I know instead NM is congruent to KL. All right. Couple more. Almost done, I promise. Next one says, quadrilateral PQRS is a rotation of quadrilateral VZYW. Okay. And it says, is angle QRS congruent to angle ZYW? And it says you don't have a diagram, but you don't need one. Okay. So think about it. What does the statement tell you? All right. So answer is yes, they are. So if I write this out, PQRS is congruent to VZYW. I know, first of all, that a rotation is a rigid transformation. Okay. So it's going to maintain my sides, my angle measurements, everything like that, right? So then if I'm looking, QRS is right there, ZWY is in the exact same place. So they are congruent. We'll write it out. They are congruent because they are in corresponding positions in the congruence statement. Okay. And that is why we said that order matters, because the order will tell you what pieces are corresponding and therefore what pieces are congruent. All right, we're going to try one more is the statement true problem. And if you get this, you're good. You understand this lesson. If you don't, maybe go back, check it out, see if you're doing it. Cool down today, you're going to practice writing these statements. So you want to make sure you understand. All right, looking at the figure, ABCD is congruent to JKLM. Is this statement true or false? Okay, so this is a false statement, and here is why. AB, then to CD, and this is going to be the hardest part. AB goes like this, BC goes like this, CD goes like this, and then it's going to come back up. If I look at the other one, it goes here. So this was 1, 2, 3, 4. Let's do it like that. This one did JK to, so JK to KL to LM, and then it would go back up. So you can see their corresponding positions are not the same. So like even if we look at this, AB and JK, AB, JK, not even close to being the same, right? So it's false because the corresponding pieces are not in the correct order. Okay, so final question. Sorry, I know I lied. What would be the correct order? A, B, C, D is congruent to what? All right, I kind of helped you by doing this. So AB would be LM, BC is MJ, CD is JK, and then back around to KL. All right, that's all we got for you. We'll see you soon.